Hi, today welcome back to another MATLAB video. Today we're going to be looking at an extra credit assignment with least squares analysis of the COVID-19 outbreak. So we all kind of know least squares. I know Professor Turnquist went over it. And so basically it's taking the residuals from a data set and creating a fitted line that will minimize these residuals, the measure of them squared, so that we can get the best fitted line uh, from this method. So the first step to do this was I went to healthnd.gov and I found this chart that shows the total cases here and then the active cases here of the coronavirus in North Dakota as a function of time. So then I just used this to find the data table, and I found all this, having the date, and then the total cases here, the active cases here, and then the new cases. For what I did, I just ended up using the total cases and the active cases. So now let's pull up my code. So the first thing I did is I kind of created this data in MATLAB. So the first thing I did is I made our X, which is 1 through 50, and these are the days since COVID-19. And then I took the Y. These are the confirmed cases, so I just wrote down the value for every day. And then Z, that's the active cases. I did the same thing as Y. All right, and then I just have a link there to that. And then input. So I know with a least squares method, you can do as many terms as possible, but I thought for what we needed, we'll do 3 terms. So that's an A naught value, an A1 value, and an A2 value. So the A naught is going to be the y-intercept value. The A1 is going to be A1 times x, and then the A2 is going to be A2 times x squared. So the first thing we need to do is create the matrices. So since I was going to plot 2 lines, I created 2 different sets of matrices. So this is for the total case, and this is for the active cases. And then I just filled these appropriately with the A naught value, A2, and A3, and then the right hand side did those for both. And then I solved to find the coefficients for the A and B matrix. So these are going to be what is, I guess you see that highlighted down here, is used to determine our line of fit for our graph. And then I calculated the error. So these are the formulas to calculate the residuals, and then I just squared those, and I found the r squared value. I did those for both the active and the total cases, and then I just did some plotting down here. So we're going to run this code and take a look. All right, so COVID-19 in North Dakota, and then days since and number of cases. So you can see starting at 0, we had the total cases rise, and then same with these active cases rise. And then, so here are our fit line for the total case and our fit line for the active case. Let's take a look at our r squared value. All right, so for our active, we got 0.97. So that's pretty good. I mean, it's better than just a straight line would be, and it's pretty high. So, and then 0.99 for the total cases. So this was a really good fit for that one. All right, take this back down. So, going back to our graphs, we can tell that this total fit is a really good approximation, or I guess fitted line of the data in same with this active case fit. All right, some discrepancies. So as you can see down here, the cases go up and then decrease. That so I guess that's kind of some of the limitations of our fit. Because we use a quadratic value, this can happen, and that's wrong. I mean that you you can't have more total cases and then get to less. So that's something we can see is an issue with our fit. Um, Also, some things we can see that there are times where this overestimates and then underestimates this data there. And then we can see that for both lines there. One thing I want to say is just because this is a fitted trend line, I guess, does not mean that we can base our assumptions or planning off this. It is increasing, yet we never know where the next data point is going to be. So while we can extrapolate from here, it might not necessarily be accurate because of all the external factors such as advances in the medical community, maybe governmental procedures such as quarantines, lockdowns, things like that, as well as smaller things like changes in the weather, and maybe that's making people go outside more. So there are always a number of factors that are determining what is happening. Uh, all right, so that's going to be it from me. If you guys like this, please remember to like, comment, and subscribe, and then hit that bell for notifications. Thank you.